We'll talk about vertical stretches and compressions. So it's like you have a graph on Silly Putty and you're pulling it up and down, you're stretching it, or you might be compressing it. So the functions look like this. You have g of x equal to, if it's a vertical one, then your a is in front of the function, okay? If a is greater, I'm sorry, if the absolute value of a is greater than 1, then you're going to get a stretch. So what you're doing is you're taking all your outputs from the function and you're multiplying it by some number. Well, if the number is greater than 1, then you're multiplying it, it's going to get bigger, right? But if the absolute value of a is, well, it's going to be greater than 0 because it's absolute value. But if it's less than 1, that's going to be a compression. So you're multiplying it by a number between 0 and 1, like 1/2 or 2/3 or something. It's not going to get larger. It's actually going to get smaller for the output. Okay? So those would be what a vertical stretch or compression would look like. So now we have some examples. Okay. So here we have, this is going to be a vertical compression because our A is 1/2. So what we're doing is we're going to take all the outputs and we're going to cut them in half. So you could make a table of values. I'll just do a little one like we've done before. We had f of x, that was that point -7, 2. Okay, so that's that far left point. But then in the g function, we're going to put in a -7 still. But then you would have, this is what you would have. You would have g of x equals 1/2 of f of -7. Well, f of -7, we know that's 2. So now we're getting 1/2 of 2, which is 1. So that's going to be the point 1. So instead of going up to 2, our output got cut in half. So let's do another one just so you can see this. So the next point that we have, that peak, was at -4, 6. But now in our graph, in our g of x, we're going to have -4 still for the input, but we'll only have 3 for the output because we're cutting that output in half. You could do that for all the ordered pairs. All right, but let's go ahead and graph it. So we'll just try to do these 2 points that we have so far, and then we'll do the others as well. So we graphed -4, -7, 1, and -4, 3. Okay, so our next point was at 0, -3. We're going to have to cut that in half then. It's going to be -1/2. And then this point here is going to stay right there because our output was 0. Half of 0 is still 0, right? And then our last point, it was at, what was it? 6, -3. So now it's going to be 6, -1/2. Or, 3/2. Okay. So then we draw it as best we can. So kind of like that. So it should look kind of like it's smushed down from the top, up from the bottom, right? So it kind of smushed the whole thing closer to the x-axis, and that would be then a vertical compression there. So that's that one. All right, so now we're going to have 2 in front of the function, and so the 2 is greater than 1, so this is going to be a stretch, a vertical stretch. And you can plug in values and do that, but when we used to put in -2 and got 4, now we're going to put in -2 and get 8. When we put in -1, we got 1, now we're going to get 2. 0 is going to stay at 0. So when we're stretching and compressing vertically, if it's on the x-axis, it's going to stay on the x-axis. Okay. 1, 2, and then 4, 8. And so we get a stretched parabola looking like that. And it doesn't take much, doesn't take a very big number to get it to really stretch. But that is that one. I think I'll try to do all the stretch and compressions on one video here. So now we're going to go with a horizontal stretch or compression. I kind of think of it like say you have a graph like this, like in trigonometry, we have something like that, and then say you're going to compress it, then it's horizontally, they're still going up and down the same, but they're getting closer together. That's not a very good picture. But I think of it like an accordion, like you're pushing an accordion in or pulling it out. So if you have g of x equaling f of, and now that multiplier is coming in, I think a lot of times they use a b there, but let me change that to a b. I'm going to say a lot of times they use a b. But it's multiplying the input and then applying the function. The vertical ones, we applied the function and then we multiplied it, so it affected the outputs. But this is going to affect the inputs, right? So that's what's going to happen here. And it works kind of opposite of what you think, but if the absolute value of b is greater than 1, it's going to be a compression. And I'll show you why when we get to an example. And if the absolute value of b greater than 0 but less than 1, that's going to make it a stretch. And we're doing this horizontally, so it's stretching. You can't see my hands, but I'm stretching them horizontally like you're pulling out an accordion. Okay, so here we go with some examples. It might be easier to show that way. All right, so we have, it's going to be a horizontal and then stretch or compression. So then you have to think, okay, it's a 2, but it works the opposite way, right? And so it's going to be a compression. Okay, so here's f of x. And then these are going to compress horizontally. You're going to get closer to the y-axis. Now let's think about our points that we have. For f of x, we've got that point -7, 2. But when I go to do g of x, if I want to get a 2 out, then I've got to put in half of -7. So which would be 3.5, right? Okay, so here's how it looks. G of x is equal to f of 2 times 7, I'll put -7 halves. So if I put in -7 halves or -3.5, then those 2's cancel and I get f of -7. And I know f of -7. F of -7 is 2. So that gives me, when I put in a -7 halves, and I'm going to rewrite that in a minute, but when I put in the -7 halves, that's what gives me an output of 2. So what I'm having to do is I'm having to cut my inputs in half so that I'll get those outputs that I know. Now I'm going to rewrite that as -3.5, comma 2. Okay, so let's go ahead and graph that. And we'll go to -3.5, which is going to be right there. And then what was our next point? Our next point was -4, 6. So we're going to have to cut that in half. We'll go down here. And that's going to be -2, 6. So because when I put in the -2 into the g function, right away I'm going to double that -2. That's going to give me my -4. And then I get my 6 output. So my outputs are staying the same. I'm choosing points that I know the outputs for because I don't have an equation here. So I can't just plug something into an equation. I have to go by the graph. Okay, so -2, 6 is right there. Now, 0, well, half of 0 is still 0, right? So 0, -3 is going to stay put right there. And then my next, so I can draw these out. It might help to see them. So we had 0, -3. And then half of 0 is still 0, so 0, -3. I'm sorry, doubling 0 is still 0, -3. And then I have a 0.30. So I'm going to cut that in half. I have to use my blue pen. So that's going to be 1.5, comma 0. And right there. And then my last point was 6, -3. So when I cut that in half, my input I'm cutting in half, 3, -3. So I get, let's see if it's going to be right there. So it's going up, it's going back down here, and then I've got this little kind of hill, kind of like that. And so the points get closer to the y-axis, and it's compressing in. Okay, so that's how that one worked. That one's a little tricky. There we go. All right, so now we have one more, and this has a horizontal, and it's going to be a horizontal stretch. So what we're going to do is we're going to take our inputs, and we're going to have to double them. So we used to have, if I make a table of values here for f of x, or just ordered pairs, either way, we had ordered pairs like -2, 4, and -1, 1, and 0, 0. And it's going to be not probably super exciting to see, but that's okay. Not all math is exciting. Okay, most of it is. Okay. So now what we want to take f of -2, we've got to put in a -4. We've got to double that. So when we plug in -4, see, we get g of -4 is equal to f of 1/2 of -4. And half of -4 is -2, and we know the output is 4 for f of -2 is 4. So that's how we're getting those points. So we're going to double these. So doubling the input to get the same output. So let's see what this looks like. So -4, 1, 2, 3, 4, 5. -2, 1, 0, 0. And so, not my data draw parabolas. And so, yeah, you can look at it as a horizontal stretch. You could say, hey, it looks a lot like a like a vertical compression. Yeah, it does. That's the nature of a parabola. Sometimes it's hard to tell because it's symmetric about the y-axis. So we get that sometimes. But I know this video was a little long, but there we go.